Okay, this is chapter 4 test. It's an old test. We're making it a review, and it's going to be similar to your test that you're going to take, but I'm going to walk you through each question. So if you don't understand something, you can see it here. It says, which equation represents the line shown? Well, first of all, we have to figure out what slope is before we even find y-intercept, or you can look at y-intercept and say, okay, our y-intercept here is -2. So obviously this one isn't your answer. -2, -2, -2. But I would have just went ahead and found the slope. Since I can see all the slopes are different, whatever that slope is, it's gonna be A, B, or C. So y2 minus y1 over x2 minus x1 is gonna be -4 plus 2 over 4, which is -2 over 4, which is -1/2. So your answer is A. It says, what is the slope of the following equation? This equation is linear, but it is not in slope-intercept form. So to put it in slope-intercept form, I need to get y by itself by adding 6x to the other side, -2, it's still negative, careful. And then I'm going to divide each term by -2. So now I can clearly see the slope because it's in slopes-intercept form, and my answer is A. Which equation is not linear? This is linear. It's in slope-intercept, or no, it's not in slope-intercept form, I'm sorry, it's in standard form. This equation is technically in slope-intercept form. That's a 1x, but that 1 is over 7, so the slope is 1/7. So that's in slope-intercept form. So standard form, it's linear. Slope-intercept form, it's linear. Here, y is by itself. Technically, it did have a slope. Here, this wouldn't be because it's x times y. We can't have them on the same side being multiplied. So this is your answer, C. Okay. Which of the following equations does not contain the coordinates 1, -3, and 2, 0? Okay, so I'm going to use this one first because it's going to be really simple. I should get 0. If I plug in 2, I get 0. Okay, if I plug in 2 here, I get 0. If I plug 2 in here, I get 1. 3 times 1 is 3. If I add to the other side, I get 6. So I don't get 0. So I think it's this one. Let's try 2 here. 6 minus 0. Yep, it's C. You could have started with this point, but I just saw the 0 and it makes things easier. It says, which of the following statements is true about the lines given? Line 1 and 2 are parallel. Line 2 and 3 are parallel. Line 1 and 3 are perpendicular, and line 2 and 3 are perpendicular. Well, I can't see any of the slopes, so I can't say whether they're parallel or perpendicular. So we need to get y by itself for each line. I move x to the other side. Notice I'm doing one step at a time. I move x to the other side, but I have to divide everything by 2. So -2, -1/2, 1/2. It says when line 1 and line 2 are parallel. No, they're not the same slopes. Line 2 and 3 are parallel. -1/2 and 1/2. No, they're not the same slopes. Line 1 and 3 are perpendicular. Are they opposite reciprocals? Yes, they are. Let's check the last one. Line 2 and 3 are perpendicular. No, they're not opposite reciprocals. Okay. All right, which equation has a graph that is a vertical line? Well, this is horizontal. Think of the horizon, the sun. And this is vertical. So when you have a line up and down like this with no slope, it cannot be written in slope-intercept form, so it must be an x equals equation. So this is in slope-intercept form. Oh, we move 5 to the other side. Oh, that's a vertical line. This one's a y equals equation if we get y by itself. so it's not that one. And this one, yeah, so it has to be part B. Number 7, some ordered pairs for a linear function of x are given in the table. Which of the following equations are used to generate the values? All right, well, I'm going to first figure out the slope. The change in y, so the change in y over the change of x is the slope. How do you get from 5 to 9? That's a 4. How do you get from 3 to 5? That's a 2. So your slope is 2. So it's not B or C. Okay, if I substitute in 3 here, do I get 5? 2 times 3 plus 1. 6 plus 1, 7. It's not that one. If I substitute 3 in here, do I get 5? 2 times 3 minus 1. Yeah, I do. So my answer is D. John rented a moving truck. The total rent cost, the total T, of a one-time fee of $50 and then 85 cents per or for each mile driven. Okay, well, if it's per or for each, there's multiplication going on with the 85 cents. So you pay $50 and then 85 cents per mile. So it wouldn't be division. It has to be A. You don't start paying 85 cents, then $50. That doesn't make sense. Number 9. A line with no slope, we said no slope, does not have a y-intercept. Which equation could fit this description? So if you have no slope, it just has to be an x equals equation. That means there shouldn't be any y's involved. So it wouldn't be y equals 5. That's a horizontal. It wouldn't be this one or this one. It'd have to be C. You could get x by itself. Okay, if you need to pause the video at all, go ahead or rewind and go to the back. Write the point slope form of the equation of the line that passes through -2, -1, and 7, -4. So, y minus y1 equals m times x minus x1. This is point slope form. So we need a point and we need a slope. x1, y1, x2, y2. I do not care what point you use, but just pick a point. So you could put here -2 and -1, or you could put 7 and -4. I don't care which one. Now we need to figure out what slope is. So y2 minus y1 over x2 minus x1. -4 plus 1 over 9 equals -3 over 9, which is -1/3. -1/3. See how much work I'm doing? That's how much work you should be doing on all of your stuff. There's a lot of work going on. Okay, so I wrote a point and I wrote a slope and we're done. I wanted it in point slope form. Number 10 says, write the standard form of an equation with a slope of 2/5 that passes through 0, -3. Well, if it's 0, -3, we know that's a y-intercept. So y equals 2/5 x minus 3. Well, that's in slope-intercept form. They want it in standard form. And standard form is when you have ax plus by equals c. So the x and y are on the left and the constants on the right. Sorry. So we need to move the x to the other side. And remember two things. We have to make it positive, the x value, and we have to get rid of fractions. So if I'm dividing by 5, I need to multiply by 5 to make this 10 over 5, which is 2x, minus 5y equals 15. Standard form. Write the slope-intercept form of an equation with a slope of -2 and it passes through the point -1, 5. M is -2. So I like to use point slope form and then rearrange rather than finding M and then finding B. So your slope is -2. Your x is -1. Be careful with those negatives. When I distribute, it's going to be -2x minus 2. I'm going to add 5 to both sides. Okay, so slope-intercept form, yep. Slope's -2, yep. Write the slope-intercept form of an equation of a line that passes through the points -4, 2, and 1, -4. All right, so we're going to use point-slope form again because it's nice to just substitute in the point and the slope. So I'm going to put in, I like 1, -4. You didn't have to use that one. You could have used the other point, but I like this one. I don't know why. Probably because of the 1. I have to figure out slope. So -4 minus 2 over 1 minus -4. Be careful with those y2s and y1s. -6/5. All right, let's just make sure. -6 over -5. No, -6. Yep, that's right. -6/5. So y plus 4 equals -6/5 x. Oops. Plus 6/5. Oh, we need it in slope-intercept form, so we have to subtract 4 from both sides. I can quickly do fractions in my head. If I want it to be over 5, I just multiply it by 5, and I'm going to subtract 20/5, which would make it -14/5. You don't have to do that. You could have done 6 divided by 5, enter, subtract 4. But it should give you this. All right. Write an equation of a line that is parallel to 3x plus 2 and passes through the point 3, 2. Okay, so y minus y1, m times x minus x1. We have to fill in a point, and we have to fill in slope. The point is 3, -2. Your slope is 3. So y plus 2 equals 3x minus 9. Subtract 1 from both sides. That's it. Did they say it had to be in slope-intercept form? No. If I left it like this, would have that been okay? If I made that positive? Yeah, as long as it's a linear equation. They just said write an equation. It says write an equation of a line that is perpendicular to this line and passes through this point. Well, I can't see the slope here. So I have to rearrange this into slope-intercept form. I divide a negative by a negative to make it positive. Okay. So point-slope form is my fave. Your x1 and y1 are here. Oh, but I need to be perpendicular to this slope. So I need to be negative and flip. I could be done. Or if I rearrange in slope-intercept form, it could be this. So these are both correct. Number 15 says, identify the slope and y-intercept. Graph the line on the coordinate plane. Well, y needs to be by itself, so I'm going to move 2x to the other side, making it negative, and then I'm dividing by 3. This stuff never goes away, so you better learn it now. It's going to be here in Algebra 2 and pre-calc, okay? Your slope is -2/3. Your b is 5. So you begin with b, and you move with m. You could go down 2, right 1, 2, 3, or you could go up 2, and to the left 3. Oh, I didn't go down 2 for that one. I wondered why it looked weird. There we go. If you don't have a beautiful straight line, something's up. Okay. So that is the first page. Now your test is going to be a little bit shorter. This is why I made it review, because it's a little lengthy. I'm going to print out 2 tests. Okay. And then constructed response. Constructed response is what you're going to see on keystones. When you are 9th grade, you take what's called a keystone. It's kind of like your PSSAs in middle school. So as a ninth grader, you take only one test, and it's in mathematics, and it's called the Keystone. Okay, you take it in ninth grade. You don't have to take a math test ever again unless you do not pass this. Then in 10th grade, you take a biology Keystone, and you take an English Keystone, and then you're done. So if everything goes as planned, you're done after 10th grade. So to prepare you for that, here's some open-ended questions of what it would look like on your test. It's called constructed response, okay? Because your response is constructed. It says, you will pay an activation fee and a monthly fee for cell phone services. So when you buy a cell phone, you have to pay what's called an activation fee. Pretty much charging a bunch of money just to get a cell phone. And the table shows that the total cost of the cellular service over the number of different months. Explain why the situation can be modeled by the linear equation. Okay, why can something be linear? Is there a constant rate of change? I can see easily up here, we're going by twos. So this is going to be my input and this is my output. There's a change of y over change in x. And is it consistent? If it is, then it's linear. So I see 2 every time here. Well, if it's 2 every time here, it better be the same every time here. So how do you get from 137 to 209? 72. How do you get from 281 to 209? 72. 353 to 209? Well, not 209, I'm sorry. 353 to 281? Can I type? Okay. 353 to 281. 72. And I bet 425 minus 353 gives you 7. Yep. All right. So our rate of change is 72 over 2. So it says, explain why the situation can be modeled by a linear equation. There is a constant rate of change. Change in y over change in x is 72 over 2, which equals 36. Now see how nice that response is? You want to make your responses as thorough as possible because somebody's grading these. And it's on a test. Okay, it says write the equation of a line that represents the total cost of a function of the months of service. So if I have a cell phone, how much is the month of service? Well, I like using point slope form. So we realize our slope was 36. We just figured it out, and we can pick any x and y value. So my equation for this, I could leave it like this, but you can do this, or you could, well, you kind of have to answer the next question. So let's just simplify this. Okay, because this is our rate of change. So the change in y, so the total cost is $72 every 2 months. So the total cost is $36 per 1 month. You're like, how would you do that? Well, it's change in y over change in x. Well, the change in y is total dollars, months of service. $36 every month. So that's really cheap. And then $65 was to start. So $65 must have been the activation fee for the phone. Okay. But it's showing the total amount for 10 months, $425. Calculate the total cost of service for 2 years. Well, if we're going by months, 2 years is 12 months. So you have to make sure you're in the right unit of measure. So $36 for every month, which is 12 months, $65 to activate the phone. How much did that phone cost you for the year? And like I said, this is cheap. So you got a cell phone, thank you mama and your dada, okay? Or if you're paying it for yourself, good for you, okay? So $497, that's a lot of money. Okay, another constructed response. Oh, scatter plots. I do like scatter plots. Okay, The scatter plots you can use in real life. Okay, determine what relationship, if any, exists. So it says calories burned during exercise. So as time increased, you see the calories increased. So it says determine what relationship, if any. So as time increases, calories increase. So as time increases, because that's your X value, we go with X first, calories increase. So positive correlation. I could have said better. As the time increases, calories increase, therefore a positive correlation. Okay. Part B asks you to use these points from here to write the equation of line of best fit. Now, do you have to use these 2 points? No, if you were just trying to write an equation, but I gave these to you so that everybody's answer is consistent. I love to use point slope form. I would just use x1, y1. It's the first one there. You could use the other. It doesn't matter. And your slope would be 280 minus 80 over 32 minus 10, which is going to be 200 over 22. Okay, so you can leave it as 200 over 22, or you could put it as a decimal, but that wouldn't be as accurate. So just leave it as 200 over 22. Now, do you want to put it in slope-intercept form? Well, let's see the next question. Predict the calories burned after an hour and a half. Well, if I'm going to be substituting something in, I'm just going to leave it like this. So it says predict the calories burned after an hour and a half. Well, we're going by minutes here. So an hour is 60 minutes, and a half of that is 30. So we're going to put in 90 minutes in for X. Because Y is our calories burned. That's what we're trying to figure out. So when I put 90 in for X, I'm going to get 80. So 200 over 22 times 80 is going to be 200 times 80 divided by 22. Okay. Then I'm going to hit, I don't like that. So I'm going to hit math. I have the fraction buttons highlighted. So it's going to be 8,000 over 11. Get used to uncomfortable numbers. Okay, then we're going to add 80 to both sides. And we're going to get 8880 over 11. But you wouldn't say I burned 8,880 calories divided by 11. You would say, oops, I burned about 807 calories. That's a lot of calories. Must have been doing some intense workout. Okay, if you have any questions, feel free to email me. This is due by Sunday night.